Okay, let's work a problem that is very similar to Chapter 8, Exercise 2. I did have a problem like this that I gave as an example, but I showed a lot of other information in that video and I confused a few folks because not all of that's necessary to solve the problem. So imagine we have 8 rural schools that want to form a cooperative to bring advanced science and math tutoring to the area. They want to have 2 separate tutoring facilities optimized for location between these 8 schools. They also have the requirement that no school is more than 20 miles from the nearest tutoring site. So when you're going to solve a problem like this, you'll have data. So you can see you have a table here that has 8 school names, the X and Y coordinates, and the number of students interested in participating in this program from each school. And you have to think about, what is my objective going to be? I want to ensure that using a weighted average based on number of students participating, both tutoring locations are in reasonably optimal places relative to these schools. And second, we have a constraint. I can have no school that's more than 20 miles from the nearest tutoring facility. And third, I have to select my decision variables. So if you folks are trying a little too hard to solve these problems, what you should do is set up the model in such a way that solver solves the problem. So I'm going to come down here below the data table, and I'm just going to highlight 4 cells, and it'll get evident why here in a second. I like to make mine yellow and put a grid around them because I am going to say this is the location of tutoring facility number 1, and this is the location of tutoring facility number 2. This is the X coordinate, and this is the Y coordinate. Anytime you do this, to ensure your formulas work as you begin to do this, put dummy values in these decision variable slots. So I'm looking here at the current data, and I'm going to guess. I'm going to try to place these reasonably close. That will improve the likelihood that your model will converge. So I'm actually going to put the numbers in here for a couple of the actual schools. So I'm just going to pick these 2 in the middle, and I'm going to say 22, 31, which is Bridge Creek, and I'm going to say 19 and 8, which is Blanchard. So I know those are going to be 0 distance items in those 2 cases, okay? So that will give me good seed values. Now I have to start building some formulas. I'm going to calculate a distance to tutor location 1 and a distance to tutor location 2. And I'm going to do a formula in here. And I'm simply going to say the X coordinate of the school minus the X coordinate of tutor location squared plus the Y coordinate of a school minus the Y coordinate of a tutoring location squared, and then I'm going to take the square root of that whole thing, and that looks like a reasonable number to me. Now, so that I can copy and paste this and make this work really well, I'm going to have to lock a few things into place. So I'm going to come up here and I'm going to do it actually in the menu bar. For me, it's a little easier to see because it's color coded, and I'm going to make sure that that C21 reference is locked in place, and this D21 reference is locked into place. So when I copy down the page, it will work correctly. I'm going to go ahead and enter. Okay. Now, what else I'm going to do? I'm going to lock the C column into place for the school and the D column into place for the school as well. Because what I'm going to do is I'm going to come up here. I'm going to copy. Whoops. I click here. And I'm going to click paste. Okay. And now I'm going to edit the second formula. And I'm going to do it by dragging because it's kind of convenient. I said I was, and my mouse is not cooperating. So I'm actually going to do it by typing then, I guess. So I'm going to go down here and I'm going to change this reference so that it's looking at tutor location number 2. So it's in row 22 and row 22. Okay, so you can see there that it's now highlighted the correct cells. So that's the distance from Dibble to those. And now I'm going to copy down the page. And yes, indeedy, Bridge Creek is 0 distance from tutoring location 1, and Blanchard is 0 distance from tutoring location 2, just as we expected because we put them there. Now we're going to stretch on out. Now the next thing I want to know is which tutoring location is, how far away is the nearest tutoring location. You don't need to find out which one is, but I'm going to do a minimum distance column, and I am simply interested in what is the minimum between this distance and this distance. Okay. I'm going to come down the page. And again, no surprises in the numbers that we're seeing here. So this one's 21 miles away, this one's 19 miles away to the nearest one. And remember, we had a requirement in here. The school wants to make sure that no tutoring location is more than 20 miles, and using our seed values, we've got one that's 21, from a tutoring location. So I'm going to come right here, and I'm going to create a constraint, okay? And I am going to call it distance constraint. Change my alignment so it'll be pretty here. And 20 is my limit, right? Well, and I'm going to find out what's my distance actual. What's my actual farthest distance? So I'm going to do a max formula. I'm going to highlight all these cells. And I'm currently at 21. So in a minute, I'm going to have Solver compare these and force the model in. Now finally, I'm going to do my overall weighted. So, and I'll call this a weighted minimum distance. And what I'm going to do is I'm going to multiply that minimum distance tutoring location times the number of students that were interested in that school. Copy down the page. Okay, so there we go. And now right down here at the bottom, I don't like how I laid this out, but it'll be okay. I'll put a label right here. I'm going to make a cell I'm going to call total weighted distance. Change this alignment so I can make this pretty. And I'm going to highlight this one in green. This is going to be my objective. I'm going to put a box around it. And I'm simply going to sum all of those weighted distances. Okay? So now I have a model. I have explored the data. I have calculated distances. I've done things. This is not the solution. We're not there yet. Remember, we're going to let Solver optimize this for us. So I'm going to go to Data, Solver, and pop open my Solver cell. So my objective, if you remember, is this right here, this weighted total distance. And we don't want to maximize it. We want to minimize it so the kids have the least total combined travel time. We're going to get that by changing the variable cells that were our decision variables right there. Okay? The book calls it decision variables. Excel calls it variable cells. These are your variables. These are what Solver gets to manipulate. Okay? And then we're going to add a constraint. And our constraint is very simple. And a tip on the constraint. Your cell reference on the left should be the one you have a calculation in. And then you got to pick whether it's less than, equal to, equal, it's going to be an integer, etc. In this case, less than or equal to this constraint. Okay? And I'm going to click OK. And there it is in my model. I'm going to click Solve. I'm going to say OK, keep the solution. And yep, I feel pretty good about this. So you can look through and see that it moved where my tutoring locations are. It dramatically reduced the total weighted distance. The farthest school ended up being Goldsby, which is exactly 20 miles from the nearest facility. And if you look over here, it does have, it's in kind of an interesting location, maybe, you know. But I think this looks like a pretty decent solution. It does look like one of the tutoring locations landed right on top of the Wayne School District, which makes a lot of sense to me because it has the most students interested. What you will find is if you run this type of a solver several times in a row with different seed values, you will get different solutions for where to put these locations. But that's because there are multiple legitimate solutions many times that have very similar total weighted distance. Solver solves this by iterating some things. Don't get too wrapped up about that. This gets you to a really good starting place. and I hope this time this helps you a lot. Thank you.